welcome co-founder and CEO, Confluent, Jay Kreps.
Welcome to Current 2023. I couldn't be more excited to be here, and I hope you are as well. This is a bit of a new tradition. This is only our second Current. We had a long history of Kafka summits, a number of those. The idea starting last year was to kind of broaden the tent a little bit. What we realized was there was so many incredible things that were happening around data streaming, the ecosystem of stream processing, that it wasn't just Kafka. There was a whole ecosystem of things that we wanted to bring to the forefront and have that be key topics in the sessions, have that be things you could see in the expo hall. And I think we've done exactly that with the lineup that we have today. And I couldn't be more excited about it. And I'm going to be talking today about the evolution of this ecosystem, the evolution of data streaming, a little bit about where it came from, how did it come about. And throughout the sessions today, we'll talk a little bit about where it's going. What's coming next, what's some of the work that Confluent's done, what's happening in the larger industry. But I'll start in the beginning. Where did this stuff come from? You know, the work that I did on streaming with Kafka in the early days, it was really motivated by a fundamental disconnect. You know, something that wasn't quite right in the world. You know, the puzzle pieces that didn't quite fit. And that was this really simple observation that in, the company I was working in, LinkedIn, all the data was generated in real time. And in fact, I think this is true in every business. You know, business is fundamentally an activity happening in reality. It's continuous. It happens all day, throughout the day. Yet for us, all the most sophisticated data processing, all the best things we could do with data were happening in batch. And even the technology that we had that was more real time, it was databases that were fundamentally about freeze the data in place, run a query at that point in time, and move on. And yet that was kind of at odds with how the business worked. The business was this continuous thing that was happening all the time. And I think this is really inherent in the way we've thought about data. Ultimately, data technology came out of the world of storage. It was about how do you take a pile of bytes, look up the right bits, scan it in the right way, process it, get a result, move on. It was a storage-oriented technology. But in the modern world, that's a little bit at odds. We don't have just one application or one system. We have hundreds of them or thousands of them. And that means there's little piles of data scattered all over every company that somehow have to come together into one thing, into one business, into one way of interacting with customers. And I think many of the fundamental problems in software today are about this picture. They're about this big mess, about how do these things come together. It's no longer how do I store my data, how do I query it. It's about how data flows. It's about how things connect. It's about how we build one big software system out of many little ones. And this big mess is what you get when the fundamental primitives you have, the tools at your disposal, are kind of at odds with the problem you're trying to solve. They don't quite model reality. They don't quite fit with it. And it's not like there's, hasn't been any technologies for working with data as it moves, for moving data around. There's been a whole slew of things. When I was at LinkedIn, we had, live services that would handle RPCs, REST calls. We had, ephemeral messaging queues. We had big ETL jobs that would dump out files and ship them around and process them. We had a bunch of batch processing in the data lake. And when we were looking at how could we make this better, how could we generalize it, one of the things that seemed like it would be a great idea was data streaming. And this wasn't a new idea. The idea for stream processing had existed, at least in the computer science literature, for over a decade. This is kind of a late 90s trend, but it never went anywhere. It never caught on. It never became mainstream. And when I learned about this, it was new to me at the time. And I thought, why doesn't everything work this way? Why don't we do everything with streaming? And when you ask people that, they would say, well, that's kind of a specialized niche. It came out of the query processing world. It's very computer science-y. So is that true? When you pull the thread on something, you try and understand, is that really true? Is this fundamentally a niche? And this is what I heard when I asked people. I would say, why? Why the world is happening continuously. Why doesn't our technology work that way? And I would get a couple different answers. they kind of mostly fell into three categories. One was, yeah, you can do this streaming stuff, but it's not really fully general. It's not going to be as expressive. It's not as easy to write programs that way. It's harder to actually build real systems like that. And the other answer was, OK, even if you could solve that, it wouldn't be efficient. It would be too slow. It would be too costly to run systems like this. The kind of big scale-out computing that we do in modern businesses, you can't do that with real-time streaming. And the final answer I would get was, OK, even if you could do all that, you won't get the right answer. These streaming things, they're kind of lossy. There's just real-time streams of data coming. It's dropping on the floor. You'll get some wrong answer. The state of the art at the time was to kind of maybe go back and recompute it in batch to fix all the things that were broken in the streaming side. And so these were the three limitations. And as a result of these limitations, people thought, oh, this is indeed, it's just some little niche of streaming things for things that are very fast and very big, but kind of broken. And there'll be a few use cases for that, but it won't be everything. But that didn't really quite satisfy me, because ultimately the world is working continuously. The technology needs to do that. And so the question is, are any of these fundamental limitations? Are these laws of physics? Is there some theorem in computer science that says that this limitation will always be there? Or are these just flaws in the tools of the time? Are these just things we hadn't done yet? And that's where, again, you start to pull the thread and try and find out. And so we started with generality. Is it the case that streaming things have to be less general? And when we looked at the technologies that were out there, actually they kind of fell into two categories. There were tools for processing the data of the past. If you dump out a table of data or a file of data, that's the data of the past. It's yesterday's data. It's the things that you collected. It's all the stuff that has happened. If you run some kind of processing on that, that processing is old. I don't know how old. Depends on when you got the data, but it's old, right? So this is all about processing past data. And the other category of tools that we had were about future. They were about processing the future data. If you build a service and you bring it up, it doesn't go back and process yesterday's requests. It processes the new things coming in now. If you start up some application with a message queue, it'll take new requests, but there's no history of all the messages it got in the past. So we had one category of tools that could do this rich, sophisticated data that would bring all the context from history. And then we had one category of tools that would just take simple live requests. And one way of seeing streaming was a kind of specialization, a niche. But another way of looking at it is something that's a generalization. And this was kind of the core idea in Kafka, was to generalize that idea of the past data and just tack on the end the future. You could think about the old data stored in one of these streams as like a file or a table. That's the data from the past. And all the data that's going to get added to that stream, that's the future. It's kind of obvious, but it actually really helps to have these abstractions, this fundamental abstraction of a stream that allows systems to be built that generalize both of these categories and that do sophisticated processing on what's stored, but can keep running as new data arrives. And this isn't just about the stream itself. It's also about the processing. The same is true for stream processing. There's the ability to take these streams and process them just as you would a table of stored data. Be able to have processing that runs up until the current time, but then keeps going as data arrives. And this is the generalization of streaming, where you can take any kind of batch query, any kind of batch job, and allow it to just keep going. And so when you think that way, then not only is streaming as general as batch processing, it's actually a superset. It's a generalization. It actually makes it more powerful. And so that was the first of these three limitations. And that was kind of a big aha. It was like, oh, OK, actually, this could be even better. And then you're left with these other two, this problem of scalability and efficiency. Can we actually make this fast? This problem of transactional correctness. Can we make it easy to build programs that get the right answer? And you might think, well, OK, maybe there's a very general model of computation for streaming, but if I can't solve these other problems, it's not really going to be that mainstream. And the early development of Kafka was aimed at these two. The early development was, first of all, about scalability. It was about how can we make something that is fast enough to compete with transferring around big files. scanning tables, something that's really cheap to be able to operate at scale and that can handle all the different types of data. And the work after that was on correctness. It was about replication, so this could be a durable and dependable stream that you could come back to. And it was about transactional processing, so that you could build layers on top that would do rich transformations, be able to read from multiple streams, create output streams that were fundamentally and correctly in sync, that didn't have duplicates or incorrect processing. And it didn't stop at that stream layer. The world of stream processing grew up around it. And it turns out that stream processing can also be made equally scalable and equally correct. And at least to me, this wasn't surprising. When people said that batch processing was inherently more efficient, I thought that was a little weird, because if you know anything about how a data warehouse works internally, it uses a data flow engine, which kind of takes stored tables of data, turns them into a stream, runs them through a bunch of operators to process them, takes that stream and stores it back in a table. And so if you say, well, you can't make stream processing as efficient as batch, that's a little bit of a surprising thing. And sure enough, systems have come around that have taken these ideas, that have matured them, that have built fault-tolerant models for processing in parallel that make this scalable and make it transactionally correct. And so at that point, we realized, hey, all of these supposed fundamental limitations aren't really there. It's work to address them. It takes time to reach the same maturity. But there's no law of physics that says that you can't do this in real time. And if you do that, then you have something which matches the problem in reality, which matches the way a business actually operates, which matches the fact that data is being generated all the time, but is actually as general and easy to use. And that really has been the journey in Kafka in the world of stream processing, I think, from the early days till now. That's been what we've been working on. And so I think the question you could ask is, well, where do we go next? Now that we have solved some of these fundamental problems, what do we do with this? How does it evolve in the world? And I think that's what the rest of this talk is going to be about. And I think it's actually very exciting. When you think about where this can go, I think it's really going towards ubiquity. I think this is a technology that is going to be a fundamental part of data architecture, that's going to be about how data flows across organizations, for all types of data in every organization, for all the data on Earth. And it turns out it's actually so ubiquitous that it's not just the data on Earth, it's even some of the data beyond. And to talk about that, I'm going to welcome to the stage a very special guest, Joe Foster, who is at NASA, who's going to talk to us about the space streams, the streams of data that are coming from outside of Earth. So Joe, you want to come on out? So welcome.
Thanks for having me.
Maybe you could tell us a little bit about yourself and your role at NASA.
Sure. So it's hard for me to believe that I actually just hit my 5-year anniversary with NASA last week. And so it's been quite a journey, to say the least. So when I started 5 years ago, in the interview process, I had a very simple mission: lowering the barrier to adoption for cloud computing technology for mission, right? There was no ideas around migrating things from the data center, no application rationalization. So it sounds easy enough, right? But wait, there's more, as the phrase goes. My hiring manager in the interview was very candid with me, and I applaud him for that. And he said, to be honest, it's not mission difficult, it's pretty much mission impossible. We have a large geographically dispersed workforce. We have a large variety of different mission types. We don't really know what the requirements are. We don't know what the mission demand is. We don't know who the customers are, right? And so oh, by the way, we have a one-time lump sum of money to invest in this, and by the end, you better have a functional service with customers that has a break-even cost model, and hopefully this all works out, right?
And you said, where do I sign up?
Yeah, I said, sign me up. Sounds like it's going to be awesome, right? And ironically to say, we had an operational system within 10 months, and here we are 4 years into operations. We now support 155 projects across all 10 of NASA centers. So it's been pretty tremendous growth, yeah, to say the least.
That's really incredible.
Yeah,
go ahead.
I would say, and like a lot of high-performing orgs, along the way, we're constantly reevaluating our tech stack, right? And we had stumbled across this kind of self-organized Kafka community of practice about 2 years ago. And we said, hey, this looks like something that we really want to invest time in. And that sort of led to us having conversations with you all about FedRAMP and helping you guys get through the FedRAMP certification process for the last 2 years. So
that's awesome, Joe. It's been an honor to work with you guys. I'd love to hear, last year at Current, you guys won an award for a really cool use case, GCN. Maybe you could tell us a little bit about what that is, why it's important to NASA.
Sure. Yeah, there's two really cool missions that are out there that are award-winning. The first, as you mentioned, we won the Data Stream Company of the Year award at Current last year for a project called GCN. Anybody can go to gcn.nasa.gov. GCN stands for the General Coordinates Network. And the way it works is it has a publisher and subscriber model, and observatories all over the world publish alerts in real time when they witness any kind of transiting phenomenon in the sky. And anyone can subscribe to those alerts, whether you're a NASA researcher at an academic university, or let's just say you own a telescope and you're a novice at home, right? You can subscribe to those real-time alerts, and then when you get them, if you're in the area of observation, you can go outside and you can witness, and we can kind of crowdsource observations on these kind of things, right? It's a capability that we didn't have before. And we won Data Streaming of the Company of the Year last year. We also won a NASA Internal Honors Award as well. And then the other one that you sort of alluded to in the lead up is a project called Daphne. And so we are entering the era of petabyte scale science, which is a challenge for the way that we've traditionally done business as an agency. And so most IT organizations don't have ground stations all over the world as part of their IT footprint, but for NASA we do. And the way we had done business traditionally was each mission, as part of its build and commissioning process, would build their own mission-unique hardware and mission-unique software, and they would get installed at the pedestal of those ground stations. And it became a very challenging O&M process to maintain that hardware over time, and oftentimes it fell to groups outside of that mission to maintain. And so with Daphne, we've moved to standardized racks of hardware, and we've offloaded most of the computational heavy work to the cloud using serverless processing. And by doing this, we've saved US taxpayers hundreds of millions of dollars by avoiding those tech refresh costs. So another exciting process.
That's really fantastic. So I'd love to hear about what's next. What happens now?
Sure, there's some really, really exciting work happening right now. So if everybody will humor me for a second, just close your eyes, let's imagine the future together, okay, right? The year is 2035, 12 years from now. That may sound like a long ways away, but it's not. It'll fly by. The iPhone just turned 16 years old, believe it or not, so 12 years is going to fly by in a pinch. At this point, the Artemis program has delivered us humans living and working on the surface of the moon for the last decade, and we're preparing to send the first human expedition to Mars by 2040, right? Your alarm goes off. You got a flight to catch. You're going to run to the airport to catch Current 2035, hopefully back in Austin at that time. And it
was hard to get to space this year, let me just say.
Yes, I understand. And you reach over to your smart device and you order a cup of coffee. You say, hey, I'd like a cup of coffee. Please have it delivered to my front door from Starbucks, right? And 5 minutes later, you look out the window and you see a drone setting down and dropping that cup of coffee off on your front porch, and it flies away without spilling a drop. Now keep thinking, what is it going to take for that drone to get from your nearby Starbucks to your front porch, right? What does the terrain look like? Are there trees? What are the buildings? What are the surroundings? What's the weather, right? That drone is going to have millions of data points streaming to it every minute to make those kind of calculations. And oh, by the way, there's not just one drone, there's hundreds of drones potentially doing this, right? So now everybody open your eyes, right? If this is the world that you want to live in, it's going to take a lot of R&D work to get there, and NASA is the agency that's equipped to sort of facilitate some of this R&D effort. And so we've started something that's called the Data and Reasoning Fabric, right, where we're trying to democratize data by creating this data ecosystem. So I encourage everybody, if you want to live in a world where we can have drones autonomously deliver Starbucks to your front door, go to drf.nasa.gov to learn more about our data ecosystem project that we're just getting started with. So,
and if you don't like that, if you're a Luddite, then I guess you just stick with the batch processing. Is that the
batch processing? You could drive to Starbucks and pick the coffee up yourself.
Yeah, then you get a drive. All right. Well, thank you so much, Joe. This is really, really cool stuff.
All right. Thank you.
Awesome. And for people who want to learn more about what NASA is doing, they do have a talk here on GCN. I don't know if you want to...
Yeah, there is a deep dive this afternoon in breakout room 1 on GCN at 4 p.m., so I encourage anybody who wants to learn more to come check it out.
Awesome. Thank you so much, Joe.
All right, thanks.
I love the space streams. So, I was talking a little bit about this journey journey towards ubiquity. How does this turn into something that's everywhere? And I think that's really what's happening now. We're going from a world where data streaming was an ingredient in certain applications. Certain applications that had to have real time, where it was worth all the effort of getting this stuff working together. But as it becomes easier, as these fundamental problems are resolved, as this technology is more and more ubiquitous, data streaming really becomes a platform. It becomes something that has a fundamental role in the architecture of companies. And that's what we're going to talk a little bit about through the rest of these keynotes. We're going to talk about this big data mess. This is kind of the picture of every company if you zoom out a little bit, this kind of tangled web. And we're going to talk about how we can reform this, how data can flow in a simpler and better way, and this idea of a data streaming platform. And to make this happen, to make this a reality, to make this part of the architecture of every company, it's really important that the technology evolve. If we go from a world where we started with Kafka as this kind of bare bones, low-level commit log that's difficult to get up and running, but can work at large scale, we need to evolve from that to something that is ubiquitous, that can be operated as a cloud service in every organization, and that has the complete set of tools for working with streaming data. How do you work with data and make that easy enough to make it part of every application that needs it? And these are the fundamental capabilities of this new platform. This ability to not just take the stream of data itself, to read it and write it, the kind of core of Kafka, what it's always done, but actually to be able to do more, to be able to connect into all the systems that have data and capture these streams, to be able to govern these streams at the large, to reason about their correctness and keep them safe, secure, and correct, and to be able to do real-time stream processing. And I think this is what's really coming out of this ecosystem, is a new platform around data streaming that has these capabilities. And to talk about what this means, why it's important, what companies are doing with it, I want to welcome to the stage our Chief Product Officer at Confluent, Shaun Clowes.
Thank you, Jay. It's wonderful to be here at Current with all of you today. And I love where Jay kind of ended up there, this powerful idea that with streaming we can change our relationship with data. And that we can move from a world where we're just decoupling systems to also be able to decouple teams too. And I'd like to explore this idea in a little bit more detail, and I'm going to frame it across two key questions that are preventing enterprises from really capturing the value of all of their data. First, how do you integrate data across all of your applications and systems to deliver customer and employee experiences that make sense? And second, how do you embed data and analytics into all of your teams, business units, and departments to make better business decisions? You can think about data in the enterprise as existing across two major estates. The operational estate, where it's used to run the business, and the analytical estate, where it's used to understand the business. Now, traditionally, those two estates actually used to live pretty much as actual technology silos. Because in the operational estate, you mainly had a relatively limited number of big applications, things like ERP or CRM or mainframes, and they had a bunch of operational databases they were connected to. And if you wanted to make them work together to deliver an experience, you'd pretty much just wire them together with code. And the analytical estate was pretty simple too. There was often just one big data warehouse sitting in a rack in a data center somewhere, and all you had to do was wire together a bunch of ETL to suck all the data out of the operational databases and push them into the data warehouse. But the world is constantly growing ever more complex, and I'm sure you all know what I mean. In the operational estate, the business keeps standing up new applications to power new business processes or deliver new experiences. Think about things like new SaaS apps or new microservices. And those applications come with their own new operational databases. And you still have to figure out how to wire them together with all of the other different operational systems to deliver some sort of coherent end-to-end experience. And the analytical estate is getting more complex too. It's not just one data warehouse anymore. Now you've got data lakes and cloud data warehouses and a variety of analytical and reporting tools as well. And it's an incredibly complex, expensive, tedious work to try and wire all of this stuff together. But it's not simply just a matter of complexity either. It's also a matter of increasing demands for timeliness. Traditionally, technology was a supporting function for the business, and so it probably didn't matter that much if data moved in slow, big batches between systems, and so things weren't always often in sync. But in the modern world, technology is the business, and it's the business of your competitors too. And so slow, incorrect, incomplete, out-of-date data just doesn't really cut it anymore. And even beyond that, it's not the case that data now just flows in one direction in big batches from the operational estate to the analytical estate. Now data flows from the analytical estate in real time back to the operational estate as well. Now, if we try and orchestrate this bidirectional data movement using standard pipelines or ETL, or we brute force it by hand coding connection by connection by connection, that is what creates this giant data mess that we're all trapped in. But zooming in a little bit, what is all of this data that's moving around your enterprise all the time? Well, the simple answer is it's everything that matters. It's the decisions, the entities, the actions, and the facts that make up the lifeblood of your business. And it's all moving as though there was a data nervous system. But in biology, your central nervous system can act in concert in a way that these technologies just can't. And so how can we reimagine data and information flows to enable organizations to be dramatically more effective? Well, it starts with thinking about our data, not in terms of its transports, its interfaces, its connections from A to B, but rather the much more interesting question of what your data is. That's what really matters. And once you know that that's what really matters, then you can ask what you need of your data. And what you need of your data is for it to be reusable, trustworthy and reliable, for it to be contextualized for your business, and for it to be discoverable. And once you have data that has those characteristics, then you have data that is not just bits and bytes moving, it's actually assets, literal concrete assets that drive value to your business. Now, in our community, this concept is being referred to as data products, and it's an incredibly powerful idea. With data products, the consumers of data are isolated from the complexities of the producers of the data, and the data set is decoupled from the systems that produced it. And the best bit is, we're so close. You may even recognize the pieces you need to deliver on data products in your toolkit today. We can model data products as Kafka topics, and then apply appropriate governance and processing. And we're already using tools that you probably already know. Stuff like schema registry, stream portal, KSQL, K-streams, Flink, all of those tools that are already in your toolkit. And the power of data products is really profound, because what we're actually doing here is we are escaping the vicious cycle that led us to the data mess in the first place, where we are constantly wrestling with data infrastructure. And instead of doing that, we're now focusing in on a virtuous cycle where data sets are more than the sum of their parts, and they're available everywhere across your organization to drive insights and operations. That means data is everywhere it's needed. It can be joined and used to power new business processes, all without needing to know where it originated from. Data products are an asset that drive real business value. But you may be wondering, okay, Shaun, how much value are you talking about? Well, it's actually kind of hard to quantify because the possibilities are pretty much limitless. But imagine all of the most important entities of your business, the nouns and verbs, if you like to think about it that way, but instead of them being dead rows in a database somewhere that occasionally get queried, they're living data products ready to be combined and reshaped, to be mixed and matched to solve new problems. Let me give you a few concrete examples to kind of whet your appetite here. In financial services, I might use streams for accounts and payments to build a fraud detection system. And then I might reuse those exact same data products to build a customer payment notification system in my banking application. In healthcare, in the pharmacy setting, I might use streams for drug stock and prescriptions to build an automatic drug reordering system for when supplies run low in my pharmacy. And then I might reuse those exact same data products to build a really killer real-time customer prescription management experience inside my mobile app as well. Or in transportation, I might use streams for vehicles, drivers, and deliveries to build an automated process to do work assignment. And then I might mix in additional streams for weather and road conditions to build a really great route planning experience as well, building and building on top of these assets. Now, obviously, for every business, the entities that matter are as diverse as the businesses themselves. But what they really have in common is that they represent things that really matter to that business. In fact, they often represent the things the business literally exists to manage. That's why data products are so powerful. But if we want to make data products possible at scale, we're going to need more than just streaming. We need a data streaming platform. You heard Jay talk about it. Let me walk you through the 4 key aspects of a data streaming platform. Now, it obviously all starts with streaming. With streaming, data is moving in real time to power the needs of the modern real-time world. Data isn't static or passive. It's constantly moving from wherever it was created to wherever it needs to go. It's also connected. It can reach every system, everywhere, whether that system was built to be stream native or not, and bring the data into one larger streaming whole. It's governed. Because while data is always incredibly valuable, if you're not sure that it's secure, it's trustworthy, or it's understandable, then you can't really build on top of it. You can't expose it for reuse throughout your enterprise. You have to hide it under a rock. And finally, it's processed. Because data itself is always valuable, but it tends to get dramatically more valuable if it's mixed and remixed with other data to drive increasing business context around that piece of data. So, if that's a data streaming platform, and that's what Confluent has been building towards for several years, how does it work together to deliver those data products I talked about? It's super simple. Basically, we have a suite of over 75 different managed connectors and the ability to load your own custom connectors to bring all data from any application into the streaming whole. We have our global streaming network and streaming technologies that make streaming ubiquitous. Everywhere you need it to go, real-time data can pulse like a central nervous system. We have the ability to govern the data, to apply data quality rules, to be sure that the data is trustworthy, reliable, and discoverable. And we have the ability to process the data, to mix it, remix it, evolve it, filter it, roll it up in order to deliver higher value data products. And then you can govern those data products all over again to make them discoverable, trustworthy, and reliable in that virtuous cycle I talked about. And voila, that's it. You've got your data products. And the best part is that those data products are then available to be reused in any type of application you want to build, whether it's a new operational experience or it's an analytical use. We've fundamentally erased the divide between the operational estate and the analytical estate, and in doing so, enabled a whole bunch of new use cases in ways that were never possible before. So that's pretty easy to say, but let's look at it in a little bit more detail. And to start off with, we're going to talk our way through the big kahuna, streaming. And for that, please welcome my friend and colleague, Julie Price.
Thank you, Shaun. I'm so excited to be here speaking to all of you today. And we can't really talk about streaming without talking about Apache Kafka. And the Kafka community is stronger than ever, doing some really incredible things. And while I don't have time to really go into all of that innovation this morning, I do want to shout out a couple of the things that Confluent is contributing to. So what you see on the slide, my favorites here are craft, queues, and topic directories. And you're going to want to learn a lot more about them and everything going on in the Kafka space. You'll get the opportunity to do that during tomorrow's keynote. So today, I'm going to focus on cloud. Well, many of you know that about 6 years ago, Confluent launched our fully managed SaaS product. And we knew at that time we had the opportunity to really embrace cloud-first principles. This way, we could offer a differentiated experience to all of you, to all of our customers. And when it comes to Kafka, or any other technology for that matter, you really can't just take what you're doing on premises and port it over into the cloud. You've got to do things differently. A great example of this is S3. It's really clear to any of us who use S3 that it's not just a bunch of NFS servers that are running on EC2 instances. It just feels different when you use it. And that's what cloud does. It gives us the opportunity to think differently, to design differently, to build differently. And so that's exactly what we did. We took Kafka, a system that's built to be self-managed, and we turned it into a cloud-native service. We invested years of work to do this, literally. Something like 5 million person-hours over the course of 5 years went into creating Confluent Cloud and turning it into what it is today. And at the heart of it is the engine that we call Kora. Kora solves a very unique set of challenges that come with bringing that cloud experience to Kafka. In order to do that, it has to be able to run tens of thousands of clusters for thousands of customers. It has to work across various different cloud networking, storage, and compute technologies, and optimizations have to be automated so that problems can be solved at machine scale and speed, not just at human scale. And so while Kora is still delivering Kafka, the Kafka that we all know and love, it's doing it in an entirely different way. Now, today I'm only going to have time to touch on some of the key aspects of the Kora architecture. However, if you want the full story, our engineers wrote a really fantastic white paper with all of the details. In fact, it recently won the best industry paper at the VLDB conference this year. So check out the QR code, and you can get all of the details on the architecture. So let's dig in. What you see here is the Kafka architecture, but the Kora architecture, but the story is so much more. It's designed to run at scale with strong security and tenant isolation. It runs in over 85 cloud regions across 3 different cloud providers. Kora replicates between availability zones, between cloud regions, and even between cloud providers with cluster linking. And it divides up the capacity into underlying cells that provide strong availability guarantees and limit the blast radius of any type of fault to that specific cell so everything else keeps running safely. Kora also takes advantage of different tiers of cloud storage for better resilience and elasticity. And the whole architecture works with this set of feedback loops and automated optimizations that monitor and react in real time, so keeping everything running smoothly. And with so much handled by code and not people, it's really efficient. It's so efficient that we have a surprisingly small on-call team. You might be wondering why this matters. And it matters because this is how you get the type of cloud experience that we've all come to expect. It's an experience that's fast. In May, we announced that Kora was up to 4 times faster than open source. And today, we're getting ready to roll out our next generation replication architecture that makes Kora up to 10 times faster. And of course, performance depends on workload, so your results might vary a little bit. But we are publishing those new benchmarks, so you'll be able to check them out soon. And when we talk about benchmarks, they're one thing, but delivering customer value, that's another. And one of our customers that knows a lot about speed is BMW. Now, this graph that you see on the screen is a real graph that BMW woke up to one morning. It's the latency that they saw, and they saw this speed improvement overnight. They were so shocked when they saw this graph that they entered a support ticket because they thought something was wrong. So we looked into it, as we do all support tickets, and it turns out that it was just Kora's continuous innovation rolling out to them, making things better. And what's amazing is that this kind of thing happens all the time because we are always working to make things faster. So not only does the experience have to be fast, it also has to be elastic. And you can scale up and down 30 times faster with Kora. And it has to be resilient. So Kora offers 4 nines SLA that's 10 times better than Kafka services that are not adopting this cloud-native approach. And finally, it has to be cost-effective. Now, we've already helped almost 5,000 customers save on their Kafka costs. And that's really the beauty of cloud-native, is that as we become more efficient, we make things more efficient, we just pass those cost savings on to you. You don't have to do anything at all to reap the benefits. It just rolls out to you. So one excellent example of this is that due to improvements in our intelligent tiered storage, today we're announcing a 20% storage cost reduction across the board. That'll be for all new and existing customers. You don't have to do a thing to see these savings. And speaking of savings, one of the ways that we can make things cheaper is to have a different offering for you. So prior to today, there were 3 different cluster types you might be familiar with: basic, standard, and dedicated. And I'm really excited today to be announcing a brand new cluster type in Confluent Cloud. It's entirely powered by Cora, and it's called Enterprise. Now, because of the way that Cora is architected, Enterprise can offer true elastic scaling and private networking, and you only ever pay for what you use. So I want to talk a little bit about what makes this so special. And now, if you're sitting in this room, I'm pretty sure you know that streaming data workloads by nature, they're bursty, they're unpredictable, and that Kafka was built to handle this type of workload. But it only works really well if you have the right infrastructure in place. And so when you're self-managing Kafka, you need to do some rigorous capacity planning. You need to think really hard about what is your peak going to be, and do you have enough infrastructure in place? It's hard to get right. Then you pre-provision. Often we over-provision to make sure we can handle those peaks, and that can be really expensive. And inevitably, at some point, there's not enough infrastructure. And so I'm sure some of you in this room have been paged in the middle of the night to handle these types of capacity concerns or constraints. Or maybe so you've been called into the CFO's office to talk about your infrastructure spend. And frankly, these situations, they're not fun. Enterprise is here to help. Now, all Confluent offerings, they all scale elastically, but Enterprise does it in a different way because it doesn't require reserving capacity. Enterprise has instant scaling from 0 to 1 gigabyte per second without a reservation. I am not exaggerating here. It scales instantaneously. So how does it do that? It does that through automated feedback loops that monitor your workload and assign resources when it spikes and deallocate those resources when it cools off. So there's no more waiting for hardware to provision. There's no more idle resources. And there's no more paying for more than you need because Confluent will only charge you for what you've used every hour. So not only can you save money, but you don't have to worry about that rigorous capacity planning, the monitoring. You don't have to worry about those middle-of-the-night pages or talking about your spend with the CFO. So speaking of spending, how much can you actually save? Well, Enterprise delivers 1 gigabyte per second of throughput for up to 40% less. When you take that and add in enhanced security and through private networking, our industry-leading SLA, it becomes the perfect addition to our Cora offerings. So whatever your Kafka needs are, we've got a cluster type that works for you. You can get started with Basic for a $0 investment. You can run your production workloads over the public internet with the 4.9s SLA. You can get that same SLA with the added features of private networking and elastic scale at a great price point with the new Enterprise. And when you need that highest level of isolation and scalability that Confluent offers, that's when you would go with dedicated. So there's a full suite of offerings, a full spectrum of features and cost economics. And speaking of cost economics, we're so sure about that we can beat your cost of self-managing Kafka. If we can't, we'll give you $100. So not a bad deal. Now that's it about the stream part of the data streaming platform. Now I'd like to touch upon Connect. Because after all, if you can't connect to other systems to get data, you don't have data to stream. So we offer a full suite of integrations. We've got over 75 fully managed connectors, and there's a custom connector framework so that you and the community can build connectors for anything else, and we'll host them for you. We're also taking it a step further with even deeper integrations with the new Connect with Confluent program that launched in July. With this program, we partner with technology partners for direct product-to-product integrations, common solution architectures, and a joint support model. We make it super simple for more users to access fully managed Confluent data streams from within their favorite applications. And if you don't see your favorite vendor listed here, give them a nudge so that we can get them engaged. So that's Stream and Connect. Now let's hear about a real-world example of how Kafka and Quora are at the heart of delivering a great customer experience. Please welcome Sharmi Shah to lead a discussion with Warner Brothers Discovery.
Girish, thank you so much for being here with us today.
Thank you so much, Charmy and team. Excited to be here.
So let's start with some introductions. Can you tell us a little bit about your background and your current role with Warner Brothers Discovery?
Absolutely. Hi, guys. My name is Girish. I'm part of Warner Brothers Discovery. I lead the platform engineering and operations team, really foundation to our flagship Max streaming platform. We just launched in the US, and we're looking excited to take this global. And really, with very rich content, delighting all of you guys and customers worldwide, Friends, House of Dragons, Barbie, sports, a lot of fun stuff. Very excited as part of the team, really delivering one of the amazing streaming products. A little bit about my history and background. I've been in the industry a little bit over 20 years, not to date myself. I still remember Token Ring. And I've worked in different technologies, everything from gaming, fintech, OTT video, as well as large enterprise customer solutions. Everything's about scale, complexity. That's what draws me to some of these complex solutions. And it's been an absolutely exciting journey as we have built Max and trying to take it future to global markets.
Well, your diverse experience really lends itself to success here. So let's go back to 2022 and the merger between Warner Brothers and Discovery. Can you talk a little bit about WBD's vision for launching a new app and what that meant for you and your team?
Well, absolutely. It's been an amazing journey as we have been really looking at how do we really build a global streaming platform. And it's pretty amazing in terms of the complexity it takes from moving content from glass to glass. Everything from a very complex microservice architecture that scales horizontally, at the same time really leveraging the best of all the technology teams, including our amazing partnership with the Confluent team, to really move our content and really move an experience for our customers to get engaged and enjoy all the vault of assets that we have. As part of the core platform, really it's very much cloud-built, very much built around scale, very much performant. Very common tenets that we talk about at our friends at Confluent, things around how do we get elastic, how do we very much be resilient, and it's video. So since latency is a very, very important aspect, and really making sure we can provide a very rich experience for our customers.
Well, let's talk about Barbie for a second. I mean, that was a slam dunk in appealing to broader audiences and your broader market. I was so surprised that my daughter and my sons were equally excited about its launch into the Max app. So in your quest to drive standardization of the platform that you just talked about, what factors led you to adopt Confluent Cloud as part of your core functionality?
Very good question. So very common to everybody else here and across us who are in the tech sector, data is at the heart of everything that we do. For us in the streaming business, data has different profiles. We have content data, we have customer data, we have personalization data, we have operational data. Every one of these data profiles have different requirements, everything from real-time to batch processing. And one of the key things we were trying to look at as we're getting to launching the Max app globally and other products that we work with, how do we really make data more available for our workflows and use cases? Things you've heard about today and all through the conference summit, things about how do we make it discoverable, how do you make it democratized, how do you make it accessible, how do you get better governance, how do you make sure easily available. And these are some of the things that we thought about as we were trying to build the platform and leverage Confluent Cloud. One of the key things we wanted to focus on was making sure we had a very good partner that could help us take this to market. It's important we were focusing on our core tenants to build a streaming platform. And we were looking for a good cloud-native solution that allows us to basically build this. Kafka is not new to us. Love Apache Kafka. We have been doing self-managed Kafka. But we really wanted something that could be cloud-native and really allow us to scale globally. To help you size it, we're talking thousands and thousands of basically topics, a lot of partitions, a lot of different basically consumers and producers. This is at scale. So absolutely having exciting time as we're building the platform jointly with Confluent.
Well, I mean, what a great journey, right? We are thrilled to be here with you every step of the way. And as a valued partner during your launch week, in your war room, right there with your team. So
very much.
Thank you for that partnership. We talked earlier, and Shaun mentioned, a data streaming platform consisting of stream, connect, govern, and process. As you think about the Max platform and the future and how it will evolve and grow, Are there particular components that resonated with you?
Absolutely. It's an exciting time. As I said, we are still beginning to launch a platform and grow global. And some of the thematic things we've been hearing all through is very close to our heart. I'm not saying we've solved all the problems, but we're excited about some of the challenges we get to work together. Surely, stream governance is an important aspect. The amount of data we all work with is absolutely humongous. Things around how do we really get better streaming cataloging is an important aspect. We're also looking at registry, an important aspect of how do we really make sure we have better ability for interfaces to our consumer and producer services that run on the platform. And more importantly, it's also the scale and performance. Things around the Cora engine where you think about elasticity, you think about latency, you think about performance, things about log management. Each of these are pretty hard problems you're trying to tackle, and surely looking at how do we scale this globally. So common themes that will absolutely evolve as we're looking forward to move Max into getting live sports, news, getting global, fun stuff, and more content, absolutely.
Well, we are so excited. So as we wrap up, I wanted to personally thank you for allowing me the ability to stream my favorite classic, Friends, my favorite original content, Succession, and next week, live sports, all from the same app. So
thank you so much. Thank you so much,
Thank you so much for the great conversation and the partnership, Girish.
Thank you, guys.
Now, please join me in welcoming to the stage Mike Agnich.
Thanks, Jeremy. And what a great story from Warner Brothers Discovery. It's great to know that when we're streaming Sopranos on Max, that Confluent streaming is central to making that possible. So I'm here, yeah, Confluent streaming, yes, thanks. So I'm here today to talk about stream governance. And to get this started, imagine that you're a developer who's been asked to build an application that's going to go out into the hands of ticket counters and boarding gates for a global airline. The first thing you're going to need to do is to understand what data you need. You're going to need flight data. You might need cancellation data. You might need weather data or even a CDC stream from a database. And once you find that data, you have a whole set of challenges that start to emerge. You need to understand if the data is secure. Where is it? What's it called? Do you even have access to see everything that's there? Who can you call to help if you can't figure this out? Is the data ready to scale to what you need to make your application successful? And maybe that's not your problem at all. Maybe instead the problem is all of your streaming data in your organization is flowing into a single topic. And that topic has to be untangled so that you can understand the purpose and intent before it can be successfully used. But let's imagine you push through and you launch not just one, but 3 applications that are running successfully globally. But then you get a page at 3 a.m. Something has gone wrong. And people can't board their flights in Berlin and Boston and Bangalore because a producer upstream has done something simple like changing a data type. We're in a really tough situation. At best, we're spending days or weeks trying to find data in our organization, talking to people on Slack, sending emails. We're not writing code. Our friends and colleagues are wondering why things are taking so long, and it's a real problem. At worst, we've caused a global outage. People are stranded in cities around the world because we didn't have what we needed to get things done. We've become data detectives. We're not writing code. Schema registry and stream governance were designed to solve these problems for us. Schema registry provides a common language so that our producers, our consumers, and our data platforms can all work together in harmony. But schema registry isn't enough. 18 months ago, we started to expand on this. We added a stream catalog, which allows you to tag and classify topics, schemas, every fields, any kind of data that you need in your streaming platform. We added stream lineage, which gives you a single view of how your data is connected and how it flows together. And a few months ago, we added data quality rules, which added semantic validation to the platform. But this also isn't enough. Earlier, Shaun talked about data products, artifacts of business value that are discoverable, reusable, and shareable across your organization. Streaming is the best place to build these data products because streaming is the first place your organization comes in contact with data. It's the first opportunity you have to apply schema. It's the first opportunity to improve data quality. It's the first chance you have to apply rules and policies. And it happens to also be a great way to share data across your organization. So now we get to the fun part where we get to stop telling and we get to start showing. We're announcing 2 additions to our stream governance lineup today. The first is client-side field-level encryption. Confluent has always encrypted your data at rest. A few years ago, we enabled you to bring your own keys to make that even more secure. Today, we're announcing client-side field-level encryption, which brings encryptions to the producers and the consumer so that you have end-to-end encryption to meet the world's strictest compliance regimens and to make sure that your data is always encrypted in transit and at rest through Confluent Cloud. We're also introducing our new data portal, a single interface where we bring together all streams into a single place. So as a developer, you can quickly discover what you need and securely gain access so that you can get going quickly and start writing code. So without further ado, I am really excited to welcome Greg DeMichillie to the stage to show us what this looks like.
Thanks, Mike. I've got the great good fortune to show you today both client-side field-level encryption and data portal. For the purpose of this demo, I'm an application developer, and we've made up a fictitious airline. We call it Confluent Airlines. We put the stream in Jetstream. So let me start by logging into the console to get a look at this new data portal. So here I am, I log in, and instead of an empty slate, I'm taken directly into the data portal. The data portal is my one-stop shop for all of the streams within my organization. At the very top, I have some tools there to help me do filtering and searching by different tags or other sorts of fields. A little bit lower, I can see all the recently created topics or all the recently modified topics. Each one of them has a little card that gives me the basic information I need about that particular topic, including some technical information and some metadata about it. Well, I'm trying to build a new application for my customer service agents. So let's open up the recently created and look at all the topics there. Okay, this is way too many. I'll never find the needle in the haystack here. So let me go up and start drilling down. First, I'm going to look for a data product. Well, I've still got 233 topics. Well, I know my app has to run on AWS, so let me do some technical filtering on region and cloud provider, and maybe even on how long I'm retaining the data, since I probably only need a week. Still too much. Now I'm going to search for business metadata, and I'm going to look for the word flight. And sure enough, when I do this, I've now found one stream, and it's called purchase orders. This sounds like the kind of stream I would need to build my customer service application. Let's learn more about it. On the right now, I have a panel that flies out that tells me more. Again, I get the same technical information, but now I can actually see the schema and really try to understand if this is the right data for me. I'm going to expand it a little bit, and I see there's a credit card field. Hold that thought, we're going to come back to that. Further down, I can see information like the owner, a link to the documentation, and even information about when it was created. Okay, this seems legit. Let me look and see where the data's coming from. Now I can jump straight into lineage view. And here I see in the middle my topic. On the left, I see all the sources that are feeding this topic: mobile, in-person, and web purchases. And on the right, it's currently serving one application, the booking app. I'm going to add another one, which is a customer service app. Let me request access. I'll type in a reason that I'll send to David, the owner of this topic, telling him why I need access. And I'll click request. And great, my request is off. Awesome. Now let's maybe change hats. Now I'm no longer Greg the app developer, I'm David the data owner. So as the data owner, now I get an email that says somebody's requested access to your topic. All right, let's open it up and look and see who this guy is and why is he asking for my information for this topic. Read it, he's from the app dev team, he's building a customer service, looks legit, let's review it. Now I'm taken into where I can review all my pending requests. Now you remember that credit card information? That's pretty sensitive, and it's something that the booking department needs, but the customer service doesn't. So let's imply end-to-end encryption on that data so that only the right apps have access. Well, to do that, what I want to do is I want to switch into my production environment, and I'm going to create a new rule. And this rule will say that any field that it gets at the tag PCI will automatically be end-to-end encrypted, and I'm going to put the ID of the encryption key from my KMS. Now all I need to do is tag that field. So we'll go back into the schema, we'll expand that field, we'll put a PCI tag. That's it. This field is now end-to-end encrypted throughout its life cycle, so only the right applications. Let's look at the underlying code that this did. Here's the schema that represents this particular topic. You can see that encryption rule. But we've done more than that. We've applied data quality rules. We've said that the phone number isn't just a random field. It has to match this regular expression to make sure it actually looks like a phone number. And if it fails, it should go to a dead letter queue called bad purchase orders. We also applied a data quality rule to the price that said it has to be more than 0. And in this case, if the rule fails, we send an email to the billing department. So what I've done here is I've gone beyond just specifying schema. I've combined schema and data quality rules to make a contract that specifies not just the structure of the data, but the semantics between the producers and the consumers. Great, now I feel really good about actually giving this developer access to this field, because I know they won't have access to credit card data. I'm going to approve the request. Great, let's take off the David hat, let's put the Greg app developer hat back on, and we'll switch over and we'll see what's the experience like. Now that I have access to this stream, what can I do with it? Well, here I get an email telling me I've been granted access. I'll click View Topic, and I'll jump straight into that topic and explore more about it. Now, in this case, because I now have access, I see extra fields in this metadata panel that's coming up. Specifically, I see the actual messages flowing through it, so I can see the actual messages flowing through the topic, including that credit card information that is encrypted. And if I go a little bit farther down, at the top, you'll notice there's those produce, process, and consume button. We're going to come back to that process. Now, here we are in the terminal. We're looking at the actual messages. At the top, we definitely see our booking application. Here, the credit card information is available because that application has the key. Below is my new customer service app. That credit card information is not available because it's been encrypted, and all I see is the encrypted result. So now I've got my two applications. I got my booking app. I got my customer service app. Let's actually now go back to that lineage view. And you'll notice now it looks slightly different. I see a new application on the right that's now being fed from my topic. And at the top, I see that dead letter queue that we built. So there it was. With a few clicks, I was able to navigate the complex set of data that I have available in my organization. I was able to find the right stream to get access to. I was able to request access for it and then quickly get on to building my actual application. And I was able to encrypt the data end to end. There's one other thing I do want to show you, and that's how we're thinking about applying artificial intelligence to the Confluent Cloud itself. You know, we've all seen large language models help us summarize complex information or find a needle in a haystack. Well, we've been working on how can we do that to Confluent Cloud itself? How can we build an assistant that can be a real-time tool to help you manage your infrastructure? So I'm going to give you a sneak preview of something that will be coming early next year, and that we call that our AI assistant. So let me walk over to the demo machine here. This will look very familiar to all of you. This is the Confluent Cloud console. But you'll notice there's this little button down at the bottom that I have access to that you don't yet. So now let me start to ask some questions of it. I don't know, we're talking about billing, so how about what was the most expensive environment yesterday? You try to type in front of 2,000 people. There's my answer. Pros comes back. It told me not only that production was my most expensive environment, it had access to real-time billing data to show me actually how much it costs. That's pretty cool, and it told me where it came from. Well, oftentimes if something's expensive, it's because you've got some unused resources, right? So how about show me the unused resources? This is all live, running over the network? Yes. You'll notice I have a network without a cluster, and I have clusters without topics. So if I get paged by the CFO, I've got a good place to go start digging. Okay, what else can the AI assistant show me? Well, I got a colleague named Bert, and Bert's awesome, but Bert is always running up against his resource quotas. I think we all have a little Bert in our life somewhere, right? You know, he's Bert, I'm Ernie. But here, the problem is he tends to request new quote at the worst possible time, like, I don't know, in the middle of a keynote. So why don't we find out if he's going to do that? Which Kafka API keys belong to Bert Johnson? Okay, he's got these 4 API keys, but I don't know, is he about to run out? Let me just ask that question. How many more Kafka API keys can Bert create? Bert can create 6 more, so I think I can make it through the rest of this keynote without getting paged. So that was a quick demo of the Confluent AI Assistant. We started with Data Portal and Stream Governance, and those features are rolling out next month. The AI Assistant will be available early next year. It's really a game changer in terms of the productivity that you can have in terms of operating and getting the information you need from Confluent Cloud. So that was a tour of data governance. I want to now turn it over to Konstantin, who's going to talk to us about stream processing and how do we take this data and make even more from it. Konstantin?
Yeah, thanks. It's great to be here. So we've just seen how Confluent Cloud makes it easier to share, discover, and understand the streams available in your organization. But once you know about this data and you trust it, you really want to start using it. You want to build on top of it. And that is where stream processing comes in. You've also heard Shaun talk about how stream processing can help break this vicious circle and deliver data products. These data products power a variety of use cases spanning across and also in between the operational and the analytical planes that Shaun has talked about. Use cases like ad hoc exploration, analytics, operational and analytical data pipelines, and also more transactional event-driven applications. So you could build all of these applications directly on top of your plain Kafka producers and consumers. Like you could build a web application directly on top of the file system. But in the world of data in motion, the stream processor plays the same role as the database for data at rest. Like databases, the stream processors provide higher level abstractions and common building blocks that make it more secure, more resource efficient, and most importantly, just easier to build on top of these streams. So what is this stream processor? So if we look at the stream processing landscape today, we have on the one hand Kafka Streams. It's hugely successful. I'm sure many of you use it, and it's just great at putting stream processing primitives in any kind of event-driven application. And then on the other hand, you have this whole family of tools and frameworks that go a little bit further. They take over aspects like lifecycle management, rescaling, state management, fault tolerance, and each of them comes with their own unique set of capabilities. Out of this family, we see Apache Flink emerging as a de facto standard. Let me tell you why. So first, Flink and Kafka have always been used very much together. And I think both technologically as well as in terms of adoption within companies, Kafka has really paved the way for Apache Flink. We can also see this in the adoption numbers, in the downloads. Flink and Kafka follow very similar trajectories, just shifted by a few years. And that makes sense, right? So you first have to store your streams before you can process them. This is also one of the reasons why we think Flink will reach the same massive scale of adoption that Kafka already has today. But already today, Flink is powering stream processing applications and platforms at so many companies, ranging from Netflix and Apple to Goldman Sachs and John Deere. But why? Why has Flink seen this rise, this broad adoption? So I think it really boils down to 2 things. First, a broad, flexible set of APIs that appeal to data analysts, data engineers, as well as application developers. And they unify batch and stream processing. And B, all of these built on top of the same powerful, very robust runtime that delivers low latency and high throughput for stateful computations. I think in the end, Flink just made things possible where other frameworks have hit a wall. And it turned out to be the best foundation for streaming platforms with a broad and challenging set of requirements. So, to some extent, it was only logical that in the beginning of the year, we started working on bringing Flink to Confluent Cloud. But you heard Julie earlier. It takes much more to bring Kafka to the cloud, to really bring it to the cloud, to go from NFS to S3. And the same is true for Flink and stream processing. We really have to apply the same principles that guide our Kafka-based offering: cloud native, complete, and everywhere. And that is, let me talk about each of those. So first, we really envision a truly cloud-native serverless experience. That means you focus on your logic, you focus on your apps, we focus on the infrastructure. We take care of the hard bits like application sizing, watermarking, and really upgrades on all levels of the infrastructure. And all of that completely independent of the APIs that you're using to build your applications. Consequently, the billing model also follows a fully usage-based pricing, including scale to zero, further driving down total cost of ownership, but also total cost of kind of curiosity. I think this kind of zero knobs experience is really unique in the Flink market, so I want to be very specific here. If you use Flink on Confluent Cloud, you don't set operator or job parallelism, you don't set resources. Our autopilot does that, and it just works. You don't set a watermarking strategy. Every stream, every table comes with a default watermark that is derived on the historical delays of the stream, and just works. On Confluent Cloud, you don't choose a Flink runtime version. You always use the latest version. We do the upgrade transparently under the hood, and you benefit from continuous improvements, continuous innovation. But we don't stop there. Flink on Confluent Cloud is complete. It's fully integrated into the platform, and that starts with a unified automatic view on the metadata. It continues with things like security, networking, and billing, but it also means an increasingly closer integration between our storage layer, Cora, and our compute layer, Flink, more like you would expect it from a cloud data warehouse or database. And of course, Flink is available, well, it will be available everywhere. Anywhere you want it to be, any cloud, any region. But now, enough of the theory. Let's actually see it in action. And again, we will do this in the context of our artificial airline company, Confluent. So let's roll it. So as we can see, Confluent is using environments to separate dev, staging, and prod. Let's see how we can explore this data with SQL. So the Confluent CLI comes with a SQL shell, and if you open that, your metadata is already there. It starts with catalogs, which are mapped to environments, so we see dev, prod, and staging, and we choose the prod catalog here. We enter that environment, and next in the hierarchy are databases. Databases mapped to your Kafka clusters. We have two clusters here, flights and CRM, and we set flights as our default database for now. We enter that cluster, and finally we have tables, which are of course mapped to your topics and schemas. We have two topics, flights and in-flight purchases. And we see the topics right there. So now you can use Flink to browse the data in those topics. Just select star from in-flight purchases, and the stream is coming in. And it's SQL, right? You can immediately start debugging your streams. You can run like live statistics. So for example, let's see what distinct products we have sold since the beginning of the month. Right, so Wi-Fi, espresso. But Flink SQL can do so much more. This query computes the top three products for each hour continuously. And each of these building blocks you can run independently, debug, and observe. So we can see Wi-Fi is pretty much at the top, and then cheese plate, salad, and so on the podium. Right. So, yeah. Now, we know our way around a little bit, and we can start creating some data products. And for that, we will switch topics a little bit. We will now look at the reviews that our customers can provide to us after traveling with Confluent. So please roll it again. So it seems plausible that those people who have made any of these in-flight purchases actually give better reviews afterwards. And for the rest of the demo, we'll try to find out if that is true. So for that, we switch to the CRM database, the CRM cluster. And there are two tables in here, customers and flight reviews. And we will need both of those. Let's peek into the flight reviews, select with a limit. And we see it's quite minimal, but it has the review text and it has a customer ID, which is all we need for now. But before we get to those, we need to do some preparation. We need to enrich our customers by their lifetime revenue from in-flight purchases. So for this, we use a left join because we want a row for every customer, even those that have never made a purchase. And note that we're joining across two different Kafka clusters here, the CRM cluster and the flights cluster. So let's run this. And once we have some results, well, this looks as good as something like this looks. And I think this is actually quite useful. We build our first data product out of this because others might want to use that as well. So we create our table with the right schema, and immediately we see the topic automatically being created on the Kafka side, and already has the right schema for key and value. So once we have that, we can now create a long-running insert into statement that continuously maintains that. But before we do that, let's switch to the compute pool, which we use to run that. Compute pools are a new concept, and they provide the resources to run your Flink jobs. They scale up and down according to the resources needed by the queries, and since we're not running any queries, this is currently scaled to 0. Now we've submitted the query, and we hopefully see that it's going up to 1, which of course we will see because it's recorded. We can now also go to the Flink statements, and we see this statement running here, and we see input rate, output rate, and the consumer lag, and can monitor that as it now runs until we stop it at some point in the future. Now, of course, we have saved the kind of best for last, and we will conclude this small demo and this small analysis on flight reviews by looking at two of the most recent developments around Flink on Confluent Cloud. So please roll it again. This time, we start in the data portal that you've already seen in Craig's demo. And if we switch to data here, we see our 4 original tables, but we also already see the customer's revenue table that we just created a minute ago. So as a next step, we need to determine whether a flight review is actually positive or negative. And for that, we can click on Process here, and that opens a SQL workspace. SQL workspaces are these new UI that you can use to interact with your data in Confluent Cloud using SQL just from the UI. You can save your queries, you can run multiple queries simultaneously, and you can also browse the catalog a bit. So let's run this, and as the results come in, we see, well, there is no kind of sentiment score attached to that. We already knew that. So let's change something about that. And without training any dedicated model, we can actually just call out to OpenAI and ask it to assign a sentiment score between 1 and 5. Invoke OpenAI is a Confluent-provided built-in function that will be available soon in the platform. And it's using GPT 3.5 by default here. So we're choosing all of our original fields and this new additional column. And we see OpenAI is quite generous, lots of good reviews, but we also see a few bad ones coming in. So this is definitely something that is valuable for other use cases. So let's again create a table for it. Let's materialize this result. And once the table is created, we can again run a long-running insert into statement that now will basically run forever and update these results. We see the details here, and we can conclude our whole analysis by joining these customer revenues with the sentiment. We group by non-zero revenue and just take the average of the sentiment of both of these cohorts. Now we see, well, it's actually true. People who make in-flight purchases give extremely good reviews, which, if I think about my recent flight, is actually surprising, given that Wi-Fi was the most popular product. But so we conclude this demo and actually recap. We look at what we've learned about stream processing on Confluent Cloud. So it all starts with our serverless runtime for Apache Flink. And you can use the SQL shell, or you use the workspaces to submit your queries and statements. In any case, they will run in elastic compute pools, which scale up and down depending on load, and they also scale down to 0. And you can make use of an extensive set of built-in functions, including our built-in integration with OpenAI. In the course of next year, we will also add support for programmatic APIs in Java and Python, further broadening the set of users and use cases that want to use that service. But today, I couldn't be more excited to announce that Flink has actually entered public preview as of now. So, right. That means if you are a user of Confluent Cloud, or you become a user of Confluent Cloud, you can just log in today and try all of this out. As it's still in public preview, we've started on AWS in 4 regions, and we will roll this out to all clouds and regions on our path to general availability, which we're targeting for early spring next year. Now, you've already seen a glimpse at 2 of our AI-related initiatives in the Flink demo and earlier on in the governance demo. But Kafka and Confluent is actually already at the heart of AI-related initiatives at many leaders in the industry. To give you a concrete example, I would like to welcome Stephanie to the stage, who will talk about what Notion, a leader in the productivity space, is doing with Confluent. Thank you.
All righty, welcome, Daniel.
Thanks for having me.
It's great to have you here. Welcome, Daniel. All right, so I know a lot about Notion. I'm a big Notion fan, but I don't think everyone here knows about Notion. So do me a favor and tell us, one, a little bit about your role, and then about Notion.
Great, so I lead the data and AI teams at Notion, and Notion is a connected workspace where teams can go to create and share documents, organize knowledge, manage projects, and take notes all in one place.
It's very cool. It's a connected workspace. So one of the things that I like you have with Confluent is you guys have this really diverse set of use cases, quite a breadth of them. I'm hoping here on stage you can just share 1 or 2 with the audience.
For sure. So we started using streaming for some typical, I think, internal analytics type of use cases. So we use it to power our internal event analytics pipeline. We use it for CDC piping to our data lake. But over time, we started using it to power a number of product features as well. So initially, things like powering Notion's notifications, some of our integrations, like our Slack integration, and we started using it with some of our AI features as well.
Fantastic. You had a very big product launch this year. As we talk a lot at the conference about generative AI, you launched Notion AI earlier this year very successfully. Congratulations. Thanks. Tell the group here about Notion AI and how you're thinking about Gen AI.
For sure. So Notion AI helps you work faster and automate time-consuming tasks. Things like helping you write, helping summarizing long documents, extracting action items from meeting notes, and much more.
Okay, so we've got a little bit about Notion AI. Help me out with the role of streaming as it relates to your Gen AI strategy and the company moving forward.
For sure. So it's early days. As you know, this field is moving very fast. One of the initial use cases where we started looking at using streaming was to power a feature we launched this spring called AI Autofill. If you've used Notion, you probably know that Notion databases are a collection of documents. And with AI Autofill, you can automatically add properties to those every document in that database. So, for example, a summary feature, or so it summarizes every single document in the database, or extracting key items from a document, or even using your own custom prompts. And since we have to do this updating on a regular basis for all of the documents in that database, streaming is a way that we can actually process that on an ongoing basis.
Fantastic. That is great. All right, so we've talked a lot about Notion over the last couple of days. You're here working in streaming. You're pretty far along in your streaming journey. Can you give a tip or a piece of advice to this group today?
Yeah, for sure. One of the things that we found really helpful was as we started using streaming for more use cases beyond kind of internal analytics on our data teams, we found it really helpful to invest in a small team actually building out some core libraries in our application stack to make it easier for lots of product engineers on many teams across the company to use streaming in their features without needing to really reason and think about streaming and streaming infrastructure. And that's made a huge difference in ramping up our use cases.
Love it. Very cool. Thank you for joining me and everyone here at the conference.
Awesome.
And with that, we're going to bring Jay back up on stage.
Thanks.
Cool use case and overall usage pattern. I wanted to talk a little bit about the role of data streaming in AI. This is a pattern that we are seeing increasingly in all our customers. And the setup is exactly what you would expect. We have these incredible language models that know all kinds of things about the world at large that we want to apply in our business, for our customers to actually interact and provide some kind of text interface. And the key problem in doing that is how do you combine this kind of basic language capability with the proprietary data, the facts about your company, the things that are up to date that customers want to ask about. What happened to my product? What happened with this service? Why didn't this work? And of course, when they ask, they want to know about the state of things right there, the transaction they just tried to have go through, the thing that just worked or didn't work for them. And this is something a lot of people are thinking through right now, not just Notion. And this is something that, unsurprisingly, has a similar solution. The ability to plug into the systems that you have across that big data mess, capture that data, be able to take that stream, get it into the format that you need, load it into a vector database or other storage system that can help augment these real-time prompts that are going out to large language models. We think this is incredibly interesting. Obviously, we've been working on it internally for Confluent, but we're seeing customers do this all over. And we want to make it as easy as possible to do this. We want to really help unlock this emerging ecosystem. And so I'm excited to announce today a set of partnerships and integrations, connectors across some of the leading vector databases, Pinecone, Mongo, Rockset, Weaviate. These are tools that can help index this data. And Confluent, of course, can help do that data preparation, help connect into the rest of your ecosystem, help get this to where it needs to be. And then integrations with the cloud providers and SIs that are working with companies to make this real. So if you're interested in this space, go check it out. We've actually put together an incredible demo that actually shows this stuff in action. So if you go to the expo hall, you check out our booth, you can see this whole pattern and kind of pull it apart and see how it works with a fun interactive demo. So I'm incredibly excited about this. I'll recap a little bit about what we talked about today. We talked about this growing up, this expansion of this platform from a low-level commit log to a complete data streaming platform, the complete set of capabilities. We talked about this data mess and how to solve it with the emergence of data products, sharing data across an organization in a way that's well-structured, that's meant to be reusable, that's designed for all the applications that may want it. And we heard about all these different use cases. Really cool stuff, the space streams. I think there was some jet streams. There was some streaming video. Really cool use cases from Notion. And that's not all. There's a lot more to learn. The rest of this conference is going to have incredible talks by people who are doing this at scale, in production, with some of the most exciting use cases in the world. I can't wait to see some of that. And tomorrow, we have a great lineup of keynotes that will dive into the open source ecosystems. What's happening in the world of Apache Kafka, what's happening with Flink, and beyond. And you'll hear from incredible users, technologists, from companies like BMW, JP Morgan Chase, Uber, and others. So I'm really looking forward to that. But before we go, I do have one more thing. Last year at Current, we announced Confluent for Startups. And the idea behind this was, hey, we're entering a time where money is a little tight. And for a lot of startups, they want to use the best technology, but they're trying to do it on a budget. And so we announced a program to give the first year of Confluent to startups for free. And this was incredibly successful. Over 150 companies adopted this, and we got the opportunity to work with them. And some of them have built really incredible products and technologies around this. And I think this is essential for the movement that is emerging I think it's essential for the data streaming ecosystem. So we wanted to come up with a way to do even more. And so today, I'm really excited to announce the Data Streaming Challenge. And with this, we're not just going to give out a year of free credits. We're actually going to start making investments. And we're going to do $1 million of investment for companies that are building technologies that are enabled by data streaming. And there's incredible stuff happening in all kinds of different product areas that build on this technology that's so impressive. And we want to help enable this. And so we'll be doing a little bit of a pitch competition. You can pitch some folks at Confluent, but the judges will also include some of our early investors, folks from Benchmark, Index Ventures, and Sequoia. So it's an incredible opportunity to get out there, show what you're working on to some of the best investors in the industry, and get some investment as well as some great credits to help you get going. And that's going to be announced, the grand prize, at Kafka Summit London next year. So I could not be more excited about that. Please apply. And with that, I want to thank everyone for spending the time with us. I think it's an incredibly exciting time in this ecosystem, and there's an awesome lineup for the rest of the show. Thank you all so much.